Okay, today we're going to do graphing rational functions. So if I have a rational function that tells me this, I need to list all of the parts out. So my zeros come from setting the top equal to 0. So I'm going to get a 0 at -1. And remember, zeros are also the x-intercepts. Vertical asymptotes come from making the bottom equal to 0. So I'm going to get a vertical asymptote of x equals -2. Horizontal asymptote, I check if they're the same degree, and they are. So I divide the leading coefficient by the leading coefficient, which is 1/1. So I'm going to get a horizontal asymptote of y equals 1. For my holes, I see if these are the same, and they're not, so I don't have any holes. So to graph these out, these are going to be lines, but they're going to be dashed lines because they're not actually on the graph. They just help us draw our graph. So at x equals -2, I'm going to draw an asymptote. And at y equals 1, I'm going to draw an asymptote. Now what I'm going to need to do here is I'm going to need to put my x-intercept in. My x-intercept is at -1, which is where it crosses the x line. So the asymptote is something that my graph, the part that I'm actually going to draw, gets really, really close to but doesn't touch. So since I have a 0 right here, it's going to get really, really close to this but not touch it, and then really, really close to this but not touch it. Over here there's no zeros, so my line can't be down here because that would give me a 0. So it needs to be above this, really, really close but not touching. So that's what we're doing on these guys. If I have one that tells me f of x equals x squared plus 3x plus 2 over x squared plus 4x plus 3, zeros come from the top, so I'm going to have zeros of -1 and -2. Vertical asymptotes come from the bottom, so I'm going to have a vertical asymptote at x equals -3 and x equals -1. Now I notice right away that I have the same number, so that's going to be a hole at -1. And what the hole does is it actually cancels this out, that's no longer an asymptote, and cancels this out, that's no longer a 0. Horizontal asymptote comes from if the degrees are the same, which they are. So I divide the leading coefficients, 1 divided by 1, which is 1. So I'm going to put my asymptotes in. Vertical at x equals -3. Horizontal at y equals 1. And the examples that we do in class, we're going to get a lot of them where y equals 1 for a horizontal asymptote. I'm going to put my 0 in at -2. And the hole is going to be the last thing that I draw. So I'm going to draw my graph. It's going to get really, really close down here. Really, really close up here. Since it doesn't cross the axis, it can't be down here. It needs to be up here. Now I do the hole. So the hole is actually on the green line that I drew at x equals -1. So I go to -1 on the x, I find where it is on the graph, and I put a circle there, an open circle. It's really hard to tell that this is open, but it should be open, okay? So an open circle just like this, all right? So if you're drawing in pencil, it's a little bit easier to like erase and put that hole in there. But the hole needs to be on the line that you drew.